All right, here's another example. Now what we have is an equation, and we're going to solve this using completing the square and also using the square root property, as you'll see. So this is one way that we can use multiple ways of solving this equation. So the first thing I'm going to do is bring everything over to one side, and so I'm going to write this as I'm going to add 10x to both sides, so I get x squared plus 10x minus 3 is equal to 0. So now I have a quadratic equation. But notice that if I take half of 10, that gives me 5. This is not 25, so this is not a perfect square trinomial. But let's manufacture by completing the square. Let's manufacture one by completing the square. So what I'm going to do is I'm going to separate this. So I'm going to put a parenthesis right here. So I'm going to group these two together. 10x, okay? And I'm going to put minus 3 equal to 0 over here. Okay, so inside here I'm going to complete the square. Okay, so now how do I do that? Well, I divide this by 2 and square the result. So if I divide this by 2, it gives me 5, and if I square 5, that gives me that I have to add 25 here. Now remember, if I add 25 here, I also have to subtract 25 outside to counter that, right? So to undo that, right? So to make the net effect 0. Okay? So now this is a complete square, a perfect square trinomial now, and now I know that this reduces to what? X plus 5 quantity squared. Okay? And then this combines to what? Minus 28, right? Okay, and so I get x plus 5 quantity squared minus 28 is equal to 0, and then I can what? Add 28 to both sides, and now I've got it where I can use the square root property, because now it becomes x plus 5 quantity squared is equal to 28, and then I can go from there. Okay. So, if you understand what I did, great. Let me do it the other way. Okay? Which is the exact same thing, but just slightly different. Now, let's say I want to move the 3 over here, right? So let's get the 3 over there and then have just this part over here. So it's just a different way of separating the 2. Instead of using parentheses. So now I'm going to add 3 to both sides and change this. So it's going to be x squared plus 10x is equal to 3. And now what I'm going to do is I'm going to complete the square on this side by dividing by 2 and squaring it. So I get x squared plus 10x plus 25 is equal to 3. Now if I add 25 to this side, I'm also going to add 25 to this side using, balancing the equation, right? And so now I've got the perfect square trinomial on this side, so that's going to reduce to x plus 5 quantity squared is equal to 28, which is what I got before. Okay? So just a different technique, different way of doing it, but it gives you the same result. Okay, now I can use the square root property and take the square root of both sides, And if I do that, I get x plus 5 is equal to plus or minus the square root of 28. Okay? And 28 is 4 times 7, right? So I can write this as x plus 5 equals plus or minus 2 times the square root of 7. And then all I have to do is subtract 5 from both sides. And my final answer is I get x equals negative 5 plus or minus 2 root 7. Okay. Now again, how did I get the 28 to here? Remember, square root of 28 can be written as the square root of 4 times 7, which then the square root properties tell me I can split this up in the square root of 4 times the square root of 7. And then the square root of 4 is 2. Okay? All right, that's it.